Hello. In this video, we will introduce recursive helper functions. In the preceding section, when we introduced the is-palindrome function, we pointed out the implementation is not efficient because every time we invoke is-palindrome, we create a new object for string. We can improve it using recursive helper function. So what we do is we're not going to create a new string. So we use the same string here. This is the same string, but we now have this low and high to indicate where the substring is. So the original function is the same. This is a palindrome. But now we introduce another function. This is called a helper function. The helper function is going to be recursively called. So this is palindrome. Is palindrome, and this is s, the string, and the low is 0, and the high is len s minus 1. For is palindrome, we have this low and high. If high is less than or equal to low, so now you have checked everything, they all match, and this is going to return true. Else, if s brackets low not equal to s brackets high, so this no match, return false. Else, we're going to do it recursively, return is palindrome with this s, but now low is +1 and high is -1. So this, using this two indices to indicate where is the substring. So let's look at another problem we are very familiar with. It's a selection sort. We introduced this problem back in chapter 7. Selection sort is to find the smallest element in the list, swap it with the first one, and now continue in the remaining list to do the same thing. So we did it using loop back in chapter 7. Now we can rewrite it using recursion. Using recursion, we're going to write this way here is this is sort the string. So we're going to introduce a helper function sort. So this is going to have sort this string, but the last index is now, initially is the last one here. So this is the last index. Okay, so we're going to slide the, I think this is the variation of the selection sort. So what we do is we're going to find the largest element in the list and swap it with the last one, then continue to do it. So in this way, we just write the program slightly differently. So that's what here is. So let's look at this now. We're going to sort this array. So find the largest element now and swap this largest element with the last element. And now in the remaining list, so that is going to be sort, you're going to sort this S, but the last index is now high minus 1. So this is a recursive version of selection sort. And now let's look at the recursive version of binary search. The binary search is assuming that the list is already sorted. So you compare the key with the element in the middle. If it's less than, so now your search is narrowed to the first part. If it's greater than, the search is narrowed to the second part. If there's equal, that's a match. So it's the binary search. So what we do here is binary search. This is the key, and here the size. We are going to have introduced this index low and high to indicate where the string, the list, and we are searching for now. Initially, so we're doing the binary search for the entire list. So this is the entire list, and the key is this right here, and the index is this is low, and this is high. So high is size minus 1. And now this is a helper function. Binary search is key and low, high. So this is the mid. And if key is less than list brackets mid, so now we're going to change this high to be mid minus 1. If it's equal, so this is a match. So you can return mid. Otherwise, so it's going to the second half. So we're going to have this low is now is mid plus 1. So where is the best condition? Best conditions here when low is greater than high. At that time, we're going to return the negative value here, indicating where this element would be inserted. So this is the negative low minus 1. The low is the position where you would be, where this element would be inserted. So that is all for this section on recursive helper functions. See you on the next video.